Okay, problem solving, practice of addition and subtraction. So this is where we got to write down everything we know, and most of the time it works better to work backwards. We've kind of learned those are our problem solving skills. The Diaz family is cross-country skiing the Big Tree Trails, which has a total length of 4 miles. Yesterday they skied 7/10 mile Oak Trail. Today they skied 3/5 mile Pine Trail. If they plan to ski all of the Big Tree Trail, how many more miles do they have left to ski? So I need to find the distance of, right here, how many more miles do they have to ski? I need to use what distance? Well, I have to know what they've already done. I know that it's a total of 4. And the total of 4, but they went 7 and 10, 7/10, and they went 3/5. I can work backwards starting with what? Well, I could go backwards with 4 miles, and then I could subtract off the total miles they went, and each distance, divide it by each distance, and find out how much, or subtract it by each distance. So yesterday they skied this, so I'm going to put yesterday they skied 7/10, and today they skied 3/5. So how many miles do they still have left to go? That's our M, so we'll figure that out. First, we got to add these two together to figure out. So 7/10 plus 3/5, and I know I've been writing up and down. Okay, 7/10 plus 3/5, and my common denominator is going to be 10. So this I have to take times 2. 5 times 2 equals 10. 3 times 2 equals 6. If I add those together, I get 13/10. What is that? Okay, what do we got to do? We got to figure out how many tens go into 13. Well, I know 1 does, and that equals 10/10. So I subtract that. What do I have left over? 3/10. So they went 1 and 3/10 miles already. They have 4 miles to go, so we're going to subtract 4 from 1 and 3/10. So I'm subtracting a whole number times a mixed number. So what do I want to do? I want to change everything to a mixed number. So when I do that, I know that I'm going to work with a common denominator of what? 10. So that means I'm just going to put a 10 here. 4 times 10 is 40, because this is 40/10, because if we did this, it would be 10/10 plus 10/10 plus 10/10 plus 10/10, because if I have 4 of them, I got 10, 20, 30, 40. So this would be 40/10 subtracted by 1 times 10 is 10, plus 3 more is 13/10. 13/10. So if I look at this, if I subtract that, I know I have a tens here, and I get 27/10. And if you're not sure about that, we can subtract it off to the side. I don't mind that at all. 7, 3, 2, 27/10. All right, now I got to ask myself, because that's an improper fraction. To simplify it, I got to get it into a mixed number. 10 goes into 27 2 times, so that's 2. 2 tens is 20/10. Subtract it. I have 7/10 left. So how much do they have left to ski? 2 and 7/10. And I know that I can't simplify this anymore because 7 is a prime number. And with your prime number, you have to have what? It has to go into the 10. It does not. Is this a reasonable answer? Yep. If they went 1 and 3/10 earlier, and I have 2 7/10. If I would add those together just to double check it, that would be 10/10. That would be a whole. That'd be 4 whole miles. So that was fun. All right, guys, let's do another problem-solving one. So you're going to take the information you know. So let's look at this one. And as part of their study of Native American basket weaving, Lee's class is making wicker baskets. Lee starts with strips of wicker that is 36 inches long. From the strips, she first cuts one piece but does not know its length. Then she cuts a piece that is 6.5 long. The piece left is 7 3/4 inches long. What is the length of the first piece? Well, let's figure out. What do we need to know? We got to find out what the length of this first piece that she cut. What do we know? We know it's 36 altogether. So we had 36 altogether. And then she cut one piece off, or she cut something. We don't know. So I'm going to put N there. And then we cut another piece that was 6.5. And then we cut another piece, or we had a piece left over that was 7 3/4. So let's work backwards now. So I have how much was cut? 7 3/4 plus 6.5. And I'm going to add those first. And so I have 7 3/4 plus 6.5. Some of you are going to be able to do this in your head, and you know that a 3/4 plus a half is 1 1/4. So you would add that, but I'm going to show you to prove that. So, excuse me, find a common denominator. Well, it's going to be a fourth because 2 can go into 4. So I'm going to put a fourth here. So this stays the same. So it's 7 3/4. Here I have times 2. So this is, now I have what? 5/4. And I have 6 here. Well, this is a improper fraction. So 4 can go into 5 one time. So there's my whole one. 4, take away 4 fourths, take away 5 fourths, take away 4 fourths. I get 1 1/4. Let's add that to our 13. And we now are at 14 1/4. So this equaled 14 1/4 together. So now I figured that out. So what am I going to do here to figure out my 36? Well, I used 14 1/4. So I've got to subtract 36 subtracted by 14 1/4. Well, I have nothing to subtract here, so I could change this all into an improper fraction, but I think I'm just going to change this to take 1 away from here, and I get 35, and I get 4 fourths here. If I take 1 whole one away, and I want a fourth, it's 4 fourths. Because if I take 4 fourths, if I have 4 fourths and I subtract 1/4, I get 3 fourths. Now I just have to subtract on this side, and I get 21 3/4. So what was the cut of the first one? 21 3/4. Does that sound reasonable? Well, if I look at it, if I just estimate 21 plus 14, because I estimated that as 14, 21 plus 14 gets me to 35. That's pretty reasonable for that question. All right, there's another problem we have solved. Now what you're going to do is solve some more. You've got to work it through. If you have any questions on what I just did there, please come and ask. And we got to go to the next video.